And that's why I'm interested. I'm joining here.
Are you looking at it being permanently migratable or as a one-time lift and shift?
As a first step, just have flexible deployment decisions or capabilities. As a second step, permanently shifting around might also be relevant. But first, it's about initial decisions where a workload should go. And we are looking at environments that consist of both edge resources and cloud resources. So, yeah.
Sounds good. Thanks for joining, Ludwig.
Yeah, thank you.
By the way, just forgot to mention that this session will be recorded and the recording will be posted later on. So hope everybody is comfortable with that. Just a disclaimer.
Hi, this is Harold. Can you hear me?
Hey, Harold. Yeah.
Hello, Harald.
Hi, Ludwig.
So I'll introduce myself. My name is Ted Ross. I'm with Red Hat. I'm actually a co-worker of Daon's here, and we've been invited to demonstrate some of the stuff that we're working on with multi-cluster. So I'll be talking a little bit later.
Cool.
So anybody else wants to introduce before we officially start? Okay, I'll thought maybe someone was talking. No. So we have a couple of things on the agenda today. So first thing is the TED's presentation on the Scupper project. It's basically a continuation of what we talked earlier about. We had a session about the MQP protocol and how it can be used in edge use cases earlier this year, and we did a little bit of demo of that at KubeCon Barcelona. So Ted will introduce the Scupper project, which is something we did working on after it to make these things easier and more consumable. And I think the other topic we had here is proposal for the KubeCon North America. We had a deadline, I think, on Friday to make a proposal as a working group. So any topics around that we can discuss today and wrap up that until Friday if people are interested in proposing a joint session as a working group there. So I think, yeah, Ted, you wanna get going?
Yeah, I'd be happy to do that.
Maybe one comment. I wrote you an email. So we discussed 2 weeks ago about the KubeCon North America, and I brought in an idea whether we can cover that or add that as a potential topic, which is the network-aware scheduling. Stephen is also here now. So we discussed this 2 weeks ago, and that's the reason why I thought maybe it's a good idea to give a short presentation today. But if we don't fit it in time-wise, we have to think about an alternative, how we can do that.
Yeah, I was thinking maybe just to start discussing it as a second item in the agenda about KubeCon plans, and yeah, I think for now.
How long is your presentation? I mean, if it's 5 or 10 minutes, I think we could probably slip it in, right?
Yeah, absolutely.
I can rush through in 10 minutes, so.
Okay, since you put it on the table as a topic for the KubeCon session, why don't we do that after Ted speaks and before we talk about the KubeCon?
I can do a short version of it, so just to give you an idea, so to give you enough knowledge to make the decision, or that we can all make the decision whether it's a good idea for KubeCon or not.
Okay, that sounds great. Thanks.
Yeah, sounds good.
All right, Daon, is there a certain time limit you want me to try to adhere to? obviously we want to leave at least 10 minutes for that topic.
Yeah.
So.
I don't know. I mean, I'm not. I don't mind if we. It's a good that we have a lot of topics for this session. So I'm comfortable in extending the length of the meeting if we have too much things to talk about.
Yeah.
So whatever you're comfortable with.
Yeah, I've got another one after this. So maybe if we could leave time for other things, is 30 minutes plausible, or do you need 40 or what?
I can do it in 30. Yeah, that's probably fine. It really depends on what kind of questions are asked. So,
Yeah.
But I can do the meat of it.
So
in
I would
30,
propose
so.
for both of these presentations today, if we we can always schedule a follow up on both topics for the
Right.
for the coming weeks. So yeah.
Yeah, I'll leave you enough time.
Cool.
I'm going to share my screen and get started.
Yeah, it all looks good.
Okay. All right. Yep. Good. So as Dejan introduced, we're talking about. I'm talking about it's actually a new project that we're starting up. It's called Scupper.io, and we haven't even published our website yet because we just got approval from our trademark folks on the name. But what it is, it's not new technology, but it is a kind of a focus on a use case of an existing technology. And the upstream project in question here is from Apache Cupid. It's called Apache Cupid Dispatch Router. It's also productized within Red Hat under the name of AMQ Interconnect, and it is a networking technology for messaging. It was developed to support messaging in order to scale messaging systems out into large deployments and large multi-site deployments. And as such, it is multi-site. It's natively multi-site, so it was designed from the very beginning to be multi-site, and it works more like a networking solution than it does like a messaging solution. But what we have found over the years is that containerization and Kubernetes in particular is a really good fit for this technology, and we're actually focusing some of our effort here on the application of Apache Cupid Dispatch with in multi-cloud environments. So we're building some tooling around it. We're going to have demonstrations around it. We're going to have some sample projects and reference architectures and such that are built around this particular use case or these related use cases. And one of the reasons that we're here talking to you is that we think that the edge is very interesting application of technology because it's a way of very flexibly connecting different Kubernetes clusters. So let me just start off. I'll just go. I'm not going to show any slides, but I'm going to show you the console and the various components that are running. And what I'm showing you here is the Apache Cupid Dispatch console, and this is the topology view. So it actually shows a graphical representation of what's connected to what. So each of these circles represents a location. It actually, in this case, it represents a specific Kubernetes cluster or OpenShift cluster, where I've got one running in Amazon US East. I've got one running in Amazon Europe Central in Frankfurt. These are both running OpenShift version 4.1. I've got three of them that are more in an edge configuration where I've got one in Brno, Czech Republic. I've got one in Raleigh, Durham. I've got one running on my laptop. So each of these three are actually OKD 311. There's no reason why this can't be a mix of Kubernetes, OpenShift, and various flavors of the Kubernetes implementations. They all interoperate fine. And the other thing I should mention at the outset is that we're not doing anything here that's fancy with regard to networking. So there's no VPNs installed. There's no software-defined networking. There's nothing that's done in firewall rules that is out of the ordinary. The only thing that we're using is in these two public locations is an OpenShift route or an ingress so that we can make a connection from other points inbound. So these connections are all mutual TLS. In fact, when we deployed this network, we created a certificate authority that's dedicated to it. The certificate authority is then used to sign certificates for each of the locations. So it makes it very secure with regard to rogue elements trying to join the network. They can't do so unless they have a certificate that's issued by that authority. So it's quite locked down from a security standpoint at the top at the gross level. And let me show a little bit about what.
Are you prepared to take questions now, or do you want me to wait till the end?
Please interrupt me with questions. That would make things clearer, I think.
So I get the impression that you've got like global visibility here of what's going on with your networking, but I'm wondering, when I consume this networking from, say, a Kubernetes app, is this managing these network connections down at the Kubernetes node level? In other words, the Linux hosts, or would this be app to app in a typical use case?
I'm not sure I fully understand what you're asking there. We're not joining the networks together.
Okay.
But we and when I say I've got a global view, I have a console that's connected in. So let me show you what's going on. And if I don't answer your question, please re-ask it. But let me just show you what's going on the consoles of these clusters. So this is the one that's in the Virginia, the U.S. East. And it's got one pod running, and it's this QD router D. This is the router that is part of Apache Qubit Dispatch, and that's running here. It's also running in the EU central cluster. The way this is configured right now, these are purely pass-throughs. I don't have any actual application services running on those locations, just the router. And then if I look at the one that is on my my local laptop, I've also got the router. This looks different because it's an older version of OpenShift, but I've got the router pod itself running, which is what creates the network. And then I also have some proxies to allow for HTTP and TCP connectivity over this network. But the network is AMQP. It's a layer 7 routing network, so there's no joining of CIDR subnets or anything like that going on here. It's an overlaid network at layer 7.
Okay, so my question, I think maybe you've answered it, but I was thinking originally that you were showing application to application visibility, but you're showing router nodes here. Is that right?
Correct. Okay. This is at a lower layer than application to application. In fact, I'm actually showing both because I do have some application services running here, which are shown here. But they're in these smaller yellow circles. And again, this is not an application console. This is really more of an infrastructure console, but it is showing the connectivity. And I should also point out that these arrowheads are they depict the direction in which a connection is established. So we make a connection from more private to less private because that's the way the firewalls allow us to connect. Now, I didn't show you the consoles on RDU and Brno because these are both configured strictly as local host clusters. There's no routes to them. And I can't even physically put up a console on them because I can't route from my laptop to them. But they are connected into the network because they've established a connection up into this public presence.
Is the reason they don't have those just some administrator made that as a security decision, or just? No,
it's the way I created it. These are metal hosts that I control. So I just started up a cluster on them and didn't give them a route because I didn't need one. So,
but I think
from an edge case,
it showed from the edge case a good point, because this is usually how it would be set up, right?
Right, and these are in private networks. So, US East and EU Central are public networks. They have publicly accessible IP addresses. These are in private networks behind network address translation. They are not reachable. There's no VPNs. There's no holes in firewalls. So the only way that they can connect in is by making an outbound connection to a public location. But once that connection is established, now we have an overlay network that can flow in all directions. And that's what I'm going to show you. So you can think of these lower locations as being edge, and we can deploy these as edges in very large numbers. You know, in thousands, tens of thousands, or whatever is needed, they can be deployed in very large numbers. But I want to show just quickly how it is that this is set up, because this is actually one of the things that we have spent quite a bit of time on. And right now we have a very flat, static way of doing this. And I've got this text here. Hopefully you can read it. It's big enough. This is the description of the network, where I just declared a router. I've got one declared for laptop. I've got one for Raleigh-Durham. I've got one for Brno. I've got one for US East and one for EU Central. And in the US East and Europe Central, I provided the URL for the route. This is kind of a temporary measure. We're building tooling around to make this just automatic, but the way it works right now is I provided the route that will be used, the URL that's used to contact them. And then once I declared the locations, then I defined the connectivity. So I said, laptop should connect to US East, RDU to US East. I've actually got RDU connecting both ways for redundancy. Brno connects to EU Central, and EU Central connects to US East. And if you look at the topology, you'll see that's exactly what was created. So there's a script that takes this input, and the output of the script is a directory full of YAML files. So I have one YAML per cluster. All I did was go to those clusters, do an OC apply or a kube control apply of these YAMLs, and then that brought the network up. So these YAMLs have the secrets for all the certificates that are required. It has the the deployments for the router. It has the routes that are needed if necessary, and all things that need to be put in place. So not only do we not do anything fancy with networking here, we also don't require elevated or admin privileges. We don't need cluster-wide access. So any developer that just has a namespace available can use this. So I just have developer access to namespaces. So
one question.
Shoot.
I understood that behind each of these routers there is a Kubernetes cluster. Is that true?
Correct. Yes, they're all deployed on Kubernetes clusters.
And is this okay? So the clusters are there upfront, or is there also a mechanism to set up these clusters in the different locations?
No, the cluster setup is not part of this. That has to be done by whatever mechanisms you use to set them up. And I've set these up in different ways.
Okay, thanks.
Yep. Yeah, we don't provide tooling for setting up clusters. There's lots of people working on that, and that's not really our. We don't consider that our responsibility, but what we're doing is we're saying that once you have the clusters or the namespaces in the clusters, we will make it easy for you to connect them together. So having done that, we now have this overlay network, and what I have running down at RDU is it's a simple web service actually. It's just a website that when you access it, it echoes back the arguments that you sent to it, and it also tags on an indication of what the name of the pod is that serviced it. So if I look at this is the console on my RDU system, and if I say OC get pods, I'll see that I have a number of things running, but the HTTP simple service is the one that we deployed. And this is just a very simple web service. There are two of them deployed. So there's this JNTPN one, and there's the LCLRC version of it. So it's scaled up to 2. So if I were to I'm local on my IC proxy. I'm sorry, on my laptop. If I say OC get service here, I've got a service for my service, and I've got a service for Echo, and this is what I would use then to connect in. These are actually proxy endpoints. I don't have any services running locally. If I say OC get pods, I have only the router and these proxies, but the HTTP service is not running locally on my laptop. It's only running here at RDU. And to reach it, it's a 2-hop. I have to go out to the public and come back into the other edge to reach it. So if I were to do a curl access to that service, where I would, supply some sort of, args, for the application, or whatever it might be, then you'll see that I get a response back that said it got a get, and it was handled by the JNTPN pod. And if I do it again, you'll see that it'll balance to the other one. So I can run these, and it'll round robin locally because they're of equal cost down here. So what is happening here is, and you can think of this sort of in an edge case where, perhaps this is an edge device or an edge presence endpoint that requires some form of direct command and control. And in this, what is being allowed here then is so it actually finds the right, it automatically calculates the shortest path and uses that shortest path to direct that traffic.
So those aren't one-way comms between US East and RDU.
Correct. It's actually a little bit misleading because, as I said before, the direction of the arrow is the direction of the establishment of the connection.
Okay.
But once they're established, then everything's multi.
They are true bidirectional connections. Okay.
They are bidirectional directions, but they're established in that. And I actually think that we should add a radio button that says show direction of establishment to take away those arrowheads because they are misleading.
Yeah,
but yes.
Yeah. Well, especially when you start talking about edge isolation, right? I mean, you kind of alluded to that fact. So it's really, okay, does that mean I can't talk to that edge device and it can only talk to me? So ingressing into the clusters, or do I have the ability to ingress out to that edge? So thanks, I appreciate that.
And there's actually a couple of different security models that you can do here. You could have a trusted edge where the edge is like a full member of this network, and it could apply its own policy, because we do have the ability to apply access policy. But you could also have the edges being untrusted, where they make the connection in. Where this connection in is actually the policy is applied up here, where you can say, well, this edge, it's allowed to access certain applications, but it's not allowed to access other applications. So there's some flexibility in that regard.
And my part of my concern is my platform is really taking advantage of the scheduling and orchestration of Kubernetes to basically do some specific work on the edge on those small form factor edge units. So, okay,
great.
Thanks.
Great. So I think at this point, I'll open it to questions because, again, I don't want to take up the entire meeting, and I think there are plenty of follow-up things that we could talk about. I'll show you also that there's also a TCP-based service down here. I think I showed it to you here, the TCP Echo, and just for completeness sake, I'll demonstrate with a. I should be using Netcap. I'm using Telnet in this case. If I Telnet to this service locally, and then send a line, it can echo back and tell me which. In fact, this is the pod that's on the RDU. So I'm able to access not just web-based applications, but also make TCP connections across this network. And I can also, do more complex things at the AMQP level, like multicast, anycast, balance traffic, etc.
Is there an analog to Cupid? I mean, unfortunately, I'm not familiar with the Apache Cupid project. I had not paid attention to it. But I mean, are we talking about basically this being a replacement of things like traffic? What would be the equivalency of Cupid if there's anything else out there in the marketplace?
Well, I'm not aware of anything actually, but what we did in the messaging space is messaging traditionally is built out of brokers, and I'm going to stop sharing in case we want to go back. So it is made out of messaging brokers and messaging servers. And a lot of work has gone in over the years, has gone into building networks of these brokers so that you could hook them up and scale them out. But a lot of that networking was really done without any knowledge of how networking is done in the networking world, with manually created routing tables and such. So what we did was we separated the brokering and queuing of messages from the routing of messages. And a Qubit Dispatch router is the routing part. So it doesn't do any storage, it doesn't do any brokering, it doesn't do any queuing. All it does is get messages from places where they're produced to where they're being consumed. And that could be on a broker. So it's a great way to integrate with a broker and say that, well, I've got a queue someplace and I want to make sure my messages get routed to that queue, or they get routed from my queue to my consumer.
Okay, that makes a lot of sense.
There isn't really an analog to it. It is
okay.
Yeah. It is a networking component that runs in the messaging space. And so it's really kind of a crossover from the messaging world into the cloud networking world.
Hey Ted, I think we have a question from Cindy asking about the relation to the service meshes and this. And I know that there was some work done in this space. So can you?
Yes. Yeah. So the relationship, we get this question a lot. Like, how does this relate to things like Istio or other kinds of service mesh technologies? And it overlaps them quite a bit. Istio is a different way of dealing with how microservices locate and balance across different microservices. Istio is very edge-centric. It puts the intelligence at the edge. And I'm talking about the edge a little differently than in the context of this meeting. It's really at the at the application. Each application knows where all its possible services are and then does its own load balancing. Whereas AMQ Interconnect is a little bit more of a smarter network where, it doesn't, the endpoints are just talking to an address and they don't need to know where the destinations are. But they know that their messages or their traffic will be routed there by the network. And the network will then take care of getting things to the places where they're being serviced most quickly. Because it has actual knowledge of what is the backlog, how many unacknowledged messages have I sent to each particular server, and I can actually pick the server that is acknowledging messages more quickly and use that as a more live type of a load balancing. But there's some overlap between what we're doing and what is going on in the service mesh world. And I think that overlap will become bigger as we continue on because we are actually interested in doing a lot of the traffic management and instrumentation that you would find in one of those. Because again, we are natively multi-cluster, whereas something like Envoy or Istio is natively single cluster, and they're trying to now get it to work in multiple clusters. And a lot of the multi-cluster work is just trying to get two clusters or a star topology or a mesh topology to work, and we're supporting pretty much arbitrary topologies, even multi-hop. And again, in hybrid cloud or in edge cloud, I think it's very important because with edge, you're very often going from private to public to private. So it's, at the outset, you have two hop routes that you need to support. And a lot of the layer 3 networking based solutions aren't able to support that very well. Did that answer the question?
Would perhaps another way to look at this be that you're at a different level of the networking stack? What my perception is Istio with Envoy is very app-centric. And the whole concept of having the sidecar bonded to a specific app makes it so. Whereas this is really dealing with the underlay, a lower level of the network itself. So, they're different use cases. Otherwise, you could almost say that conceptually you could use both at once because they're at different layers of the stack.
It's possible you could even layer one over the other. I'm not sure that makes sense, but I think what you're saying is correct. Because what we're doing is we are actually doing routing at layer 7. So if you think about the history of what happened in data networking, local area networks at layer 2, with MAC addresses existed and they couldn't scale. So they basically went to an overlay of IP, which is at layer 3, a networking, so where everything was now addressed by a different kind of address, but then we were able to go across routers in wide area networks and be able to individually address things across the world. And the problem then became that we ran out of addresses. And instead of going up another layer, what the industry kind of took advantage of our client server orientation and said, well, we'll just say that the servers will be limited to we'll stick to public servers in this limited address space, but then we'll use network address translation and create huge networks of private networks where we can proliferate as many endpoints as clients as we want. Problem now is that in multi-cloud, we're no longer client server. So we're in the case where now we really want individual services in all locations to be able to address other individual services in other locations. And the makeup of the network isn't conducive to that. It's not even built for that. So what we've done with this, even though it was sort of built for the messaging space, it's applicable to the networking space, is we've taken it up the layer and said, okay, we're going to deal with addresses not at the host level, but at the application level, and where each application or each process will have its own, or each queue or whatever it might be will have its own address, and we'll allow addressing of individual processes across the entire big network.
Cindy had a question in chat. I guess her audio is not working. She can't. She's not picking up the speaker, but she's asking if there's APIs exposed for layer 3, layer 7 routing. You want to watch? It'll need to be responded in chat. She can't hear anything.
Maybe I should go look at the chat.
Thanks. Sorry.
Yeah.
I think Cindy can hear, just can't. The microphone is working.
She said the speaker is not set correctly, so I believe she cannot hear.
Okay. Is network overlay for data plane that customers can leverage to build service mesh? I assume the router only enables connectivity across clusters. I wouldn't know the IPs and service DNS names. The IP addresses in this case are really a local concern. So the IP, this is actually another one of the attributes of this network, is that it doesn't care if our private networks have overlapping CIDR or subnets. So if two edges have if they're both 10.1.1.*, then that's not a problem, because it's not expanding the layer 3 network. It is creating an overlay layer 7 network. Do you expose any L3 and L7 APIs for routing? Or a software development kit, an SDK even for the actual routing, we do not. The way that it is interfaced to is using the AMQP protocol. So if you create a listener or create a sender for a particular address, that becomes propagated through the network and accessible through the network. But there isn't an SDK specifically for setting up routes or anything like that. The routes are automatic. I'm not sure if I've fully answered your question. But yes, the API into the network at the main level is AMQP, the AMQP protocol. We have provided proxies to make that accessible via HTTP and TCP.
Cool. Seems like these questions got answered.
I left you some time.
Yeah. Any other questions on the topic? So yeah, I think but I'm looking forward to setting up the website and more work there. And I think maybe selfishly, I would like to see another presentation in a month or so to see maybe a bigger deep dive on how to set things up, how YAML look like, and all the new things that come up in this space. I think.
Yeah, I'd be curious to know what the actual deployment looks like in a Kubernetes cluster. What does that look like to set up? What type of time requirements, etc. That'd be helpful.
Yeah.
Okay. Yeah. I mean, I showed you the YAML, and this took me probably about, I don't know, less than half an hour to set up. So once I had the clusters. So and I should also mention that we did submit a presentation about this for KubeCon NA. So we'll see what happens with that.
Are metrics exposed for things like Prometheus?
They are, yes. Yes, and in fact, the metrics set is actually quite rich because the counts are at the application address level. So you can get good information about what specific addresses, specific services are doing. But yes, it is exposed via Prometheus, and it's exposed other ways as well.
That's awesome. Thank you.
Okay, thanks, Ted, for this, and yeah, looking forward to
thank you.
Hear more about this in the future. So, Harold, wanna go next?
Oh wow. Okay. I hope I shared the right screen.
We don't see anything yet.
Do you see anything?
No.
So then it was not the right screen. Ah, here.
Okay, it's loading. Yeah, I can see it.
Okay, let me really fly over it, just to give you a glimpse and an idea, so that we can better discuss whether it's a fit for the KubeCon North America or not. And maybe we can have a deep dive later in a later session. Is that okay?
Yeah, sounds good.
Okay, so what I'm talking about is the one aspect of what we call seamless computing. Maybe some of you remember I gave a short presentation demo maybe 9 months ago in this working group. And today I would like to talk about network aware scheduling. So just the overall idea that we want to solve is, or the vision that we have. So if you consider an infrastructure where you have compute nodes that are in different places, so there are some that are in the cloud, there are some in the edge, maybe some even on embedded devices. And on the other hand, you have a distributed application that consists of several workloads that are interacting with each other. So the dashed lines here is communication between those workloads, where they exchange data, maybe in one direction, maybe in both directions, with different characteristics. And now what we want to have is, we want to have a system that does the scheduling, so in the Kubernetes terminology, the scheduling, so the allocation of these workloads to the compute nodes in these different domains, done automatically and based on the requirements of the workloads and the communication between them. So that's the overall idea. So we call it here, it's a constraint-based and maybe optimized allocation of workloads. So we want to have ideally no manual interaction in this, and this is totally different to today's industrial systems, where most of the things you have a manual assignment of nodes, which is very inflexible. So that's the overall idea. Actually, our model of how this we want to make this happen is that we have some model that describes the requirements of the applications. We have a model that describes the capabilities of the infrastructure. So, and this is the compute nodes, yes, but it's also the connectivity between the compute nodes. And then we have something in the middle that we also call the scheduler that does the mapping. So that maps all these workloads to the infrastructure, considering all of the requirements and fulfilling all of the requirements. So that's the basic idea. And now comes the link to Kubernetes. Of course, Kubernetes can do such a thing. So if we think about these workloads, each of them would be placed in a container. And Kubernetes does the scheduling of these containers. So that's how we can use it. So then our compute nodes are just Kubernetes nodes, and we can map at least some of these application requirements to the Kubernetes manifest or the deployment files. We can map some of the infrastructure capabilities maybe to things that the kubelet reads out of the compute nodes itself, or that is configured in the kubelet config files. So there is some mapping to this architecture even in Kubernetes today, and but if we look at, and we have done that, so we have analyzed what is possible with Kubernetes today and the different scheduling features that it provides. So you can do already some of the tasks that we want to do, but there are also some limitations, and the most prominent limitations are that today Kubernetes has no knowledge about how the cluster nodes are networked. So it has no network awareness, and so it cannot consider anything requirement like you want to have a bounded latency between two of these workloads when they exchange data, or such things. Also, what Kubernetes cannot do is it cannot optimize the scheduling. So if we have some, let's say, cost function, it cannot provide the best solution in the scheduling. And it cannot handle real-time applications, which is also one requirement if you look at industrial applications. So actually, let me jump over this. So this is much more detail. We have gone that path quite some distance. So what we did so far, we have defined an application model in sort of a mathematical way. So we have described these workloads and the interfaces, we call them, between the workloads in a mathematical way. We have also described the infrastructure in a similar way, so consisting of compute nodes, of network links, and of network nodes that connect these links. And each of these components has parameters. So the workloads, for example, they have things that describe, for example, the compute requirements, the memory requirements, but also requirements like latency or the bandwidth characteristics of the data that are exchanged. And the same for the infrastructure components. And if we do that, and we have done that, so if you have a mathematical model of both the application and the infrastructure, you can describe the scheduler as a constraint solver or an optimization problem with constraints. And we did that as well. So you see here some formulas that represent that. So we have a sort of complete description of this. And what we also have done is we entered this optimization problem into some tools, and we played it through for some examples. So what you see here, it's very small, but it will become bigger in a minute, is an example from a funded project. It's a wind park problem that is solved, and I give you the whole picture. And what you see, or let's first concentrate on the infrastructure. So we have compute nodes that are on these different levels. So it's exactly the kind of problem that we want to solve. So we have things that are very close to the wind turbines. So these are actually embedded nodes, most of them very close to the wind turbine where sensors are attached, but they also have some generic compute capacity. We have a small on-premise cloud, so to say, so private cloud that has some virtual machines running there, which have higher capacity. We have some nodes in the cloud, also virtual machines. And we have a full network, connectivity network between this with different characteristics. So we entered that into the model, and we also have an application that runs or shall run on this infrastructure. And we have put that into these components here that are interconnected. And you see also the blue ones, those are components that are bound to specific compute nodes, because they sort of, if you take one of those here at the bottom, they read sensors. So this only makes sense on a very specific node where this sensor is attached. The other ones, so these yellow greenish ones, they can be located wherever they fit. So there is some flexibility in the deployment that we also want to exploit. And you also see the connectivity between these nodes. So each of these components, when you place it somewhere, it's sort of like connected to rubber bands, and when you put it somewhere else, these rubber bands will follow. So it's not an independent scheduling decision per one workload, but it's also depending on the other workloads that are connected to it. And now I think it becomes clear that the current scheduling mechanism of Kubernetes, which treats only a single pod at a time, does not do the job currently. So we have run through this. So we have completely modeled this example, and this is the tool that we used. We're currently using yet another tool, which has a better optimization library behind it. But this is called Minisync. Maybe you know it's open source. You see here the description of the problem. There is some more detail to that, of course. You see here one solution that the solver found, where it placed the workloads. Also, it comes with a score. So this thing really optimizes the score that you see here. It maximizes the total score that is defined somewhere else. And on the right-hand side, you see the optimal solution that is the output of this optimization run. You see here the infrastructure with the compute nodes and the connectivity between them. So you see the links, they are colored, and that's the colors according to the bandwidth utilization on these links. You see this one link here, which is in our example a DSL link that's pretty much loaded with between 40 and 60%. And these bars indicate how much of the RAM and how much of the CPU of those nodes is actually used. That's normalized, so if the bar goes totally to the right side, it's a 100% usage on that node. So actually, that's where we are standing. And now there's a couple of questions, because we have now, I think, a model. We have shown that this model also works if you use this optimizer. And now the question is, how do we bring that, or how do we bring that together with the Kubernetes scheduler? So that's the basic question. So what would be the best way to implement the mechanisms that we need for seamless computing with Kubernetes? Is it a custom scheduler, or are there other ways? There is one thing that we need for this is to treat several or to treat dependencies between pods when scheduling. So, and that's totally different to how Kubernetes scheduler currently works. So that's also an interesting problem that we need to solve. And there's a couple of other questions that come up with our ideas here. So maybe this was a quick run. I hope that the idea got across even in this very short time.
Yeah, definitely.
Very cool, Harold. And your first question there is so. I know you've seen, a bit of stuff regarding Eclipse IOFOG and the work we're starting to do in the newly forming, Eclipse Edge Native Working Group. Mm-hmm. The answer to this is yes. And so far, we've been working with a custom scheduler for Kubernetes to deal with things in addition to the stuff that you're illustrating around, very particular hardware availability on edge nodes. Does it have an RS-485 capable serial port, things like that. And I would be very interested to talk about, ways to merge your efforts, or at least to collaborate and share back what we've been doing in the non-network aware. And so we've been calling it edge aware scheduling. So I think the answer is yes. And from what I'm seeing in the market, there are so many organizations asking these same questions about how to do this stuff, but not having a standard approach. So I'm not sure to what extent Siemens is looking to, kind of branch out this knowledge that you have, but I'd say it's of really high value.
Yeah, Harold, on your slide here asking about, are there any proposals, activities with a similar objective? Yes, in the storage SIG, this has been discussed for years, in fact, and they do have solutions here. And in many ways, the restrictions on storage generally are related to networking anyway. It's really common to have a dedicated network for storage because you don't want noisy neighbor problems where heavy use of networking for network connected storage impacts compute workloads. So they've already come up with mechanisms to support this in the storage arena. It could be that some of this is reusable or not. I think to some extent it's based on labeling and taints, but it is definitely something you should look at. The path they went down was a little different than what's in place now. The modern way of getting these things into the Kubernetes scheduling is to write up a KEP, a proposal that's reviewed by the architectural committee, but storage kind of predated that as a mandate. So they went down, if you go look at the historical documents, you might not be able to pull it off the same way they did. But if you look at the mechanisms they're using to influence scheduling, that would be very applicable. There's another niche that is like this for influencing scheduling, and that's related to high availability, where people want the ability to tag things to put them into different failure domains. But the same techniques used there could also be used to influence the schedulers.
Okay.
There are also ways to actually impact the spec, admission controllers, where you can tag your workload with specific YAML, have something get an opportunity to append to it or modify it. And that might be used to accomplish what you're looking for here as well.
Okay, thanks.
I assume since you're with Siemens, I'm guessing you're in Germany. And if so, I know there's somebody, Michael Gash with my company, VMware, who's very familiar with what happened in the context of storage related to scheduling. So if you would have an opportunity perhaps to meet with him, you two might have a really interesting conversation.
Okay, that sounds...
I think he's planning on going to KubeCon North America.
Actually, I don't know yet whether I go there or whether I can go there. But meeting your colleague in Germany would be a really good idea. Yeah,
he's a regular on the Kubernetes Slack, so you should be able to contact him there. He often hangs out in the VMware-related channel, but I think he is also on the storage channel, perhaps in others. I think Cluster API as well.
Or could you write an email to him or with me on copies and make the connection?
Okay, I don't have your email, but I could if I get that.
No problem.
You can shoot me your email either on Slack or on the chat here right now privately if you don't want it to go out to the world.
I think you'd find a sympathetic ear and probably some good sounding board from the Rook team.
I just shot it here on the...
Okay, I see it. Thanks.
Cool.
Yeah, and I think if you want to give a full-length presentation of all this and kick a more lengthy discussion, I think we can do that anytime we want.
Yeah, Kilton, I'm very very keen to have that exchange with the things that you have been doing.
Sure, that sounds great.
Can we do that or maybe on some of the follow-up meetings? So basically, just.
Oh yeah, I didn't plan to do it here. Yeah, we'll just take it as a side discussion.
No. If you want, we can do it here. So I mean. Oh,
you're suggesting we do it here, just in a different session. Oh, sure. Well,
exactly.
and I think Harold, it also tends to be easier for you on the our time, West Coast time, United States evening meeting. What for you is, I think, a daytime meeting. Why don't we plan for the next one to have the discussion there and have a deeper dive?
Sure. That way, we can put it on the agenda right now.
And then we can meet outside of. Okay, great. What's the date on that one, by the way?
It's in 2 weeks, I think. So let's see. 28, right?
Oh, that one actually I'm out on holiday. So let's do it this way. Okay, let's do it this way. Let's have Harold. Let's have a side discussion, and then we'll bring some discussion into this working group and schedule a time slot for it. And that way, we can have a recording too of what we're discussing between the edge compute workloads and scheduling and the network aware scheduling. And so let's plan for that.
Yeah.
Cool. Okay, great.
Sounds great. So we have just a couple of minutes left. Any topics?
Well, we were going to discuss the proposal for KubeCon North America. There's a couple line items in the meeting notes, one I added and of course Harold's. I think they're actually arguably the same thing. My proposal was that as part of our proposal, we do a survey of IoT Edge protocols, and that's not just, like all of them, like MQTT, AMQP, there's a number of them might be relevant. And, you can already find surveys of everything out there, but specifically our value add would be talking about them in the context of what use cases they're appropriate for and what available open source tools are out there for use with Kubernetes. That maybe makes it easier to initially deploy and then do your day two management and dashboards for observability. Part of that would seem to be perfectly aligned with the presentation we just got today on the Scupper project too. And if we make this a survey, we can't go deeply into each one, but I'm thinking just like we did in China, where we could go 1 to a max of 3 slides on these different things. I think that would be a really interesting presentation. And related to these protocols would be the subject Harold just brought up of, what are the impacts when you try to combine that with actual workloads you're dispatching with the Kubernetes scheduler? How, it's not just to get the networking in place, but to use it with the applications.
I'd like to see that specific to LoRa as one example.
Yeah, maybe if others can open this doc and put, as a survey, you could help out a lot by just putting the list of things that you think should be covered.
Yeah.
And maybe I'll hit you up to do, all we have to do by Friday is to, we're actually, it's very restricted. You're only allowed 900 characters. So we might have to abbreviate this a lot. And then when it comes time, if they accept this proposal, we're basically asking the CNCF for permission for them to grant us a session. And I might ask you for some follow-up help on putting together a slide or two if you nominate something as appropriate.
Great. No worries.
Does anybody else have any suggestions for things we could propose to talk about as part of the IoT Edge working group at KubeCon North America? If you think of anything, why don't you go back to this meeting notes document and just append it in this part?
Yeah, but please do so, today or tomorrow.
Right. And I'm going to have to drop because I've got a 10 o'clock meeting.
And we can have a follow-up discussion on all this on Slack. So
Okay.
Yeah.
Okay. Bye, everybody.
Good talking to everyone. Have a great day.
Thanks, everyone. Yeah.
Thanks. Bye.
Thank you.
Bye.